Okay, so today we're going to look at graphing a logarithmic equation. So for this one, it says to graph a logarithmic function, goodness, couldn't say that, choose the values of x that will be easy to apply to the logarithmic equation. So the reason you want to be careful about the numbers that you choose is if you choose numbers that don't work very well, say with the logarithmic function that we're looking at, which in this case is, it has a 1/3 here, then you may end up with numbers that are not terribly easy to graph. Now you do have a point feature within ALEKS, so it's not necessarily required that you choose nice numbers, but sometimes it can be a little bit more helpful to kind of eliminate or apply our logarithmic properties. If you don't remember how to convert between logarithmic and exponential, definitely go back and watch the previous video because that will teach you how to go back and forth. We'll review that a tiny bit here, but I'm not going to review it a whole bunch because we're going to kind of keep moving on this next concept here of graphing. So I did create this chart for the notes page just to kind of help understand how to fill it in. But of course, when you're doing this on your own, you'd have to create your own chart. I definitely suggest that you create a chart, keep yourself organized so that you can follow along. So with this one, it's telling us to graph the logarithmic function. So g of x equals 4 log of 1/3 x. So this is what we're going to graph. So on this one, I'm saying for the x, I'm choosing 1/3 to the -2 power equals 9. And that's because if I apply -2 to 1/3, it's actually going to bring, it would be 1 to the -2 and 3 to the -2 power, which would actually switch their spots because -2, that exponent with a negative kind of tells me to move it either up or down in the fraction. It's a very simple way of thinking of a negative exponent, but that's a really easy way to apply it. So what it would really do is it would be 3 squared over 1 squared. They would kind of switch places, and that would make the 2 positive because I've switched their places. So it would really be 3 squared is 9, right? So that's where the 9 comes from. That's why it goes from 1/3 to 9, because that -2 kind of flips things over. And that's just it. Remember, a negative exponent does not mean a negative number. It indicates actually a small number or decimal, but a very easy way to think of it is that fraction idea, is that it would move the number either from the numerator to the denominator or the denominator to the numerator, depending on what it's being applied to. And since it's applied to both, it's actually flipping it over. Okay, so down here you can see that I broke this down, and this is the changing from exponential to logarithmic, because this is logarithmic for sure. It has the log in it, right? So if I write log of 1/3 9, so I'm using x is 9, well, I know that equals -2 because here's the exponential form. Basically, the equal part on the end of the logarithm is the exponent required to get there, okay? So that's why on this first one I'm saying, well, it's g of 9, I'm plugging in 9, and I have 4 with log of 1/3 9, and then I'm going to say, okay, well, that actually equals 4 times -2, because this log 1/3 of 9 actually equals -2, just like we saw down here. So this conversion is going to go a little bit faster on this one because I'm just going to keep going, but the conversion is also right here. So what I'm writing in the x column is the exponential form. What I'm writing over here is a logarithmic form, okay, because that's what we start with, but this is really a little bit more useful. I need to know what exponent I'm using here. Okay, so 4 times -2 is -8, and then I'm going to go with my next number, I'm going to go with -1. Remember, that's going to flip everything over again because it's negative, so it's really going to just be 3. So if I flip over 1/3 and then apply an exponent of 1, I'm just going to have 3 to the 1 power over 1 to the 1 power, which is just 3. So if I plug in 3 here, I'm going to put 3 because that's what this equals here. So that's the kind of part to remember is you're plugging in what it equals on the exponential form into the function, but what you're applying in the multiplication here is the exponent. Okay, so I know it's a little different going back and forth there. So 4 times the -1 is -4. All right, now we're going to go with our next number, which is 0. 0 is a very easy exponent to apply, anything to the 0 power is 1. So I'm applying 1 to my function. So if I apply 1 to this logarithm, I'm going to get 0. So I have 4 times 0, and that's 0. And I'm going to apply 1, positive 1. And so anything to the first power is itself, so it's just going to stay 1/3. So if I apply 1/3 here, 1/3 of the log is just 1. Remember, that was the exponent required to get there. So 4 times 1 is 4. And the last thing I'm going to apply is 2. So I have 1/9 here, because then I would just do 1 squared is 1. 3 squared is 9. Remember, when I'm squaring a fraction, I have to square both top and bottom. Okay. So now I'm going to apply 1/9 to my logarithm. And remember, if I apply 1/9, the exponent I needed to get there was 2. So 4 times 2 is 8. So here are my coordinates. And Alex does require you to have 5 coordinates. Okay. Sometimes it's 4, sometimes it's 5, but usually on these functions it requires 5 points in order to graph the actual logarithm. So I brought this table down just so we could see it, and this is what it will look like when you graph it. It's also going to have you put, I think the isotope might actually apply itself on this one, because this one doesn't have another feature. It's not asking you to apply that part, but that's what this dotted line is. It's the line that the function is always approaching, but never going to quite get to. It's always getting closer and closer and closer, but it never actually gets there. So it's kind of like a limit line. This is the idea here. So you can see 1, 2, 3, 4, 5 points, and then off to the left side in the tool area, there will be a graph a function tool, which will graph the logarithmic function for you. All right, I hope that helped in graphing logarithmic functions, and I will see you on the next video.